We're gonna discuss a little bit today in here about real numbers. Real numbers have a couple subsets, right? Real numbers will kind of split each other into rational numbers and irrational numbers. So what I'm gonna do, I'm gonna go a little bit this way. I'm gonna omit these little circles. So real numbers can be either rational, rational numbers, I usually call them numbers that make sense. They're very rational, right? I can predict what is going to be next, or they will end, for instance, number 2, well, as number 2, right? There's a very rational number. Or if you look in here, 2.25, nothing after that, that's a rational number. Then also what we have in here is an irrational number. And irrational numbers are numbers that make no sense. Numbers, basically, they don't know what they want to be after the decimal point. They don't know. Do I want to be, for instance, if I had a number, I guess, if I look at number 2.16823, this number doesn't know what it wants to be after the decimal point. It just keeps changing. It's unsure what it wants to be. We call it irrational number. So for rational numbers, we usually put that rational numbers are, if you look at a fraction in here, 1/2 is 0.5. Bam, done, right? So we know rational number either can be fractions or they can be terminating decimals. Terminating means something ends, right? It's done. So rational, we call them terminating decimals. We have that. Then rational numbers also can be repeating decimals. Why repeating decimals? If I give you, for instance, 0.252525, you all can predict what's going to be next, right? Again, rational numbers, they're very predicting. I know what is going to be coming next. So if I saw something like this, 0.25 with the repeating symbol above it, that's a repeating sign, I know it's rational because I can predict what is coming. So repeating decimals. Then we have integers. Integers, guys, if you forgot, they're negative numbers. So for instance, -1, zeros, or 0, and positive numbers, and they go on and on, right? Then we also have whole numbers. Whole numbers, they usually start with 0. They always start with 0. Whole, 0, 1, 2, 3, so on and so forth. And then finally, we have natural numbers.
Shia Davis, front office for dismissal.
So if I think about natural numbers, natural numbers are numbers we see in nature, numbers that we can count, right? So instance, if I look at trees, how many trees I see? 1, 2, 3, so on and so forth. Now let's look at my irrational numbers. If you look in your calculator, and if you were to put in a calculator, for instance, square root of 2, so 2, and I take a square root of it, that number goes on and on and on, and it's always a different number. If you also look at it, square root of 2, nothing times itself will give me 2, right? Square root means number that is multiplied by itself that will give me 2. There's no number multiplied by itself that will give me 2. There's no perfect square that will give me square root of 2. So irrational is, for instance, square root of 2. Number that goes on and on and on without changing, okay? I mean, that keeps changing. It's not repeating. Pi, for instance, right? Pi is 3.1417, and it just go on and on and on non-stop, and every number is different. It doesn't know what it wants to be. All these numbers in here are very much irrational. They're not sure what they want to be. If we're going to step our game up just a little bit when it comes to square roots, you will be approximating square roots. When I have to approximate a square root, I cannot use a calculator. You will have problems that will tell you estimate square root of 71. In here they want you to estimate to a integer and to its nearest tenth. Well, integers, right, are whole numbers and negative numbers and a zero. Tenth, if you remember, tenth is the first number that comes after the decimal point, right? So it has to be in there. So I have to think about actually my perfect squares to figure out what is actually square root of 71. So we're going to go through our perfect squares. 1 square, 1. 2 squared equals 4. And I need to find a number that is going to be close to 71. 3 squared, 9. 4 squared, 16. 5 squared, 25. 6 squared, 36. 7 squared is 49. Am I getting closer? I sure am. 8 squared is 64, right? 9 squared is 81. All right. So I will be taking, actually, I found out that these two, 64 and 81, are really close to 71. So the number I'm looking for has to be somewhere in the middle. So I'm going to write it to a side in here. If I took a square root of 64, the answer, the integer, right, the answer to that is 8. If I took a square root of 81, right, square root of 81 is 9. 9 times 9 is 81. And I know square root of 71. 71 is somewhere over here in between them, right? So I am looking for the answer. The answer, the integer, is going to be somewhere between 8 and 9. I have to figure it out. What is it going to be? So what times what gives me something that is close to 71? I know 71 is maybe a little bit closer to 64. So I am assuming it's either going to be 8.5 or 8.4. So I'm going to test it. I have to test it out. So I'm going to say, what if it was 8.5? Let's see if it will work. I have to figure out what is 8.5 squared. The square, right, is telling me that take this number and multiply it by itself 2 times. Remember, exponent square is opposite of a square root, right? That will be the answer. So 8.5 times 8.5. And let's start solving. 5 times 5 is 25. 5 times 8 is 40. Plus 2 is 42. Now, 8 times 5 is 40. 8 times 8 is 64. Plus 4 is 68. 5. 2 plus 0 is 2. 8 plus 4 is 12. And 6 plus 1 is 7. So my answer for 8.5 squared is 72.25. It's close, but not close enough for me. I'm going to check out if I have to kind of go back a little bit. So I'm going to try, let's say, 8.4 squared. So I need to figure out what is 8.4 squared. 8.4 squared means 8.4 times 8.4. And hopefully I'm going to get close, maybe even hit 71, I'm not sure. 4 times 4 is 16. 8 times 4 is 32, plus 1 is 33. 8 times 4 is 32. 8 times 8, 64, plus 3 is 67. 6, 5, 10, 7, 70.56, and I think I found it. The closest number that is to square root of 81 using decimals to the nearest tenth is 8.4. So square root of 71 is estimating it's around 8.4. So the integer is the whole number, right? It's 8, and the tenth will be 8.4. Sounds good?